Sure. Okay. You do or do not have to have these memorized. Remember, I think I said yesterday was the last, right? So I don't think so. I don't think I'll make you memorize them. I don't know what the other class is doing. I think enough is enough. A calculus class starts, well, actually, in the cover, front cover and back cover has a bunch of formulas written. It's more about the use of them. Some of them you should have memorized, so you don't have to keep looking up every single thing. I don't know if this really applies. These are half-angle identities. And, go ahead and write them down and then just have them in front of you when you're doing your homework on a separate sheet of paper. This should be the one set of notes, the one part that you should constantly be referring to when you're doing this. Notice we have a plus minus in front of these two because it's a choice you have to make. And I'll tell you that when we actually get into the questions so you understand where you're at and what you're doing. Notice tan of a over 2 has how many different possibilities? 3. I'm not going to delve into that, not that I probably could anyway. But remember the cosine 2 theta had 3 rules, and it was only because of the Pythagorean identities, right? I don't know if anyone knows what I'm talking about, but that's true. Now, what I've always told my regular students, because we didn't go too far in depth with 5, 6, if I have a choice, which one would I not choose of the tan a over 2s? The first one. But then, when I do one of the identities at the end, as long as I have enough time, it actually is one that kind of works nice in working out an identity. So don't just throw it in the trash. But when you're doing number questions, where you have to find the tan of a over 2 or tan of a, and the answer is a number, I'd pick the third one. Why does the third one look the easiest? Great. Why does the third one look the easiest? Because it has the least complicated denominator. Although I think the second one's just as easy as far as you working through it. And then, of course, it starts off with number examples. So these are the ones that we should not have a problem with. We should not be asking questions about, especially after I do the first one. So it asked me to do the cosine of 15 degrees. By the way, could have been done in double and half angle identities. Stop.
Okay, go away. All right, what was I saying? Okay. What's 45 minus 30? So we already did cosine of 15 degrees doing the difference identities. This one I want you to do using the half angle identity as such here. Why? Well, why is this possible? Because 1 over 2 equals 15. Okay, now remember what I said about the identities? There's a plus minus, and you have to choose. What are you ultimately finding the cosine of? The cosine of 15 degrees, which is in quadrant, which is a what kind of answer? You got to pick the positive outside of the square root. So that's your first thing that you have to accomplish on the sine and the cosine identities for half angles. Next, what goes inside here? 1 plus cosine 30 over 2. And why this can be inexact is we know the cosine of 30. What is the cosine of 30? Root 3 over 2, and you better be that fast in calculus over 2. All right, and then I just have a quick trick on this. You can kill 2 birds with 1 stone by multiplying underneath the radical by multiplying by 2 over 2. Right? That both gets rid of the fraction within the fraction, and what's 2 times 2? 4. What's the square root of 4? 2. And then the final answer actually is this. 2 plus root 3, the square root of that, all over a free 2. And that is your answer. Resume. Let's move on. Let's go through these number ones quick because you should be able to pick them up quick so we can get to 52 and 56, what I choose to do for, as far as identities are concerned. By the way, 105 is blank over 2. 210. So that's our argument that we're going to throw into the formula. But before I continue, what's the cosine of 105 going to give you as an answer? Positive or negative is what I'm asking. You got to choose the negative outside of the square root. So the plus minus is something you have to figure out for this formula. And then on the inside, it's 1, cosine likes itself, so 1 plus cosine 210, little way I have remembering, divided by 2. So this one's slightly different in for two reasons. What's the cosine of 210? Negative root 3 over 2 over 2. And then it's very similar numerically, we just have different negatives. Multiply by 2 top and bottom, and you get negative a root 2 minus root 3 all over a free 2. And that's the answer to that in exact form. What over 2 equals 22.5? 45. So it's very specific what kind of answers you can do for this. It's limited. I don't know where these come from. They can be derived. I'm sure this book does a great job deriving it. And then they force you to use this one, which is one of the 2 easier ones. So we'll just go ahead and do that. And really what the issue is after this is the simplification. What's the sine and the cosine of 45? I want to do 2 things with this one. Number 1 is not rationalize yet. Multiply by what, top and bottom? 2. Then you get root 2 over 2. I almost made a mistake there, plus root 2. Oh, and by the way, another reason why that tangent formula, that first one's tough, because you'd have to choose, is it plus or minus? So you'd have to make that, you have to think about that. Whereas these, it happens whatever's supposed to happen. There is no choice. That's what's great about those as well. So it alleviates that, oh, what quadrant am I in and what am I going to, be able to do about that? Although it would be easy because you're ultimately taking the tan of 22.5, so it would have been a positive choice. But then you have to rationalize and all that other stuff. So, whatever. And then this becomes 2 root 2 minus 2 all over, right? 4 minus what? 4 minus what? 2. So 2 root 2 over 2 is root 2. That's a lot of 2's in there. Minus 2 over 2 is what? 1. It's a nicer looking answer. I don't know. Is it fair? You know what? I'm just thinking to myself. I'm actually talking to myself in my brain. That's what that awkward silence was for a second. I want to do like one of the other ones as well. Because I know the tan of theta over 2, I just told you, use the second 2 so you don't have to choose plus minus. But we should think about this. We are finding the tan of theta over 2. Where is theta over 2 located? If theta is between 180 and 270, where would theta over 2 land then? Quadrant, actually 2. You know how I get that? This is quadrant what? 3. And then where does theta over 2 land? Well, theta over 2 lands here. What's at 180 minus, divided by 2, I mean? 90. What's 270 divided by 2? So theta over 2 would have to land there as long as it's between 0 and 360. Some jerk could come off the streets. What if it's, something greater than 360? Then that opens up a whole can of worms, doesn't it? It does. All right, so sorry if I said jerk. But we don't have to choose that, but what can we expect as an answer? A positive or a negative? We can expect a negative answer because that's what tangent is there. So then what do I do about this? I make a triangle. And then it's from that triangle I'll be able to do sine and, cosine of theta over 2 as well. But, that's all we do. So this is in quadrant 3. This is all I ever do. I don't know what the book does. I couldn't care. Anyone? Is this right? No time. All right, and then what's the hypotenuse? It is 4. The square root of 16, right? All right. Now, which one do you want to use? I like that third one, tan of theta, or was it the third one or second one? It's the 1 minus cosine over tan, or sine, I mean. 1 minus cosine over sine, right? I have it right in my head? The other one was just as fine that we used in the last example. And all the information's right here, because here's theta. This is theta. Okay, so 1 minus cosine is negative 3/4, right? Right? Not making a mistake. Over sine of theta, which is negative root 7 over 4. What would I do first? Well, okay, I guess I could do that now. I think last hour I did 4/4 plus 3/4 is 7/4. That actually would have been nice. Because what's 7/4 over root 7/4? What happens to the 4s? They cancel. But I guess I could keep going along this line. This is 4 plus 3 over negative root 7, which is negative 7 over root 7, which is, anyone? Negative 7 root 7 over 7, which is negative root 7. See, what would have been more interesting in this question is if I asked what's this, let's do sine of theta over 2 once. What's sine of theta over 2 with this given conditions up here? All the same could be given because all it is about drawing theta's triangle and then using that information. By the way, sine does not like cosine. 1 minus, negative. Just the way I remember it, right? Is that what the sine one is? Okay, but here's the problem. You would have missed this if you're not thinking. I have to choose. Where did I just say theta over 2 is? What quadrant is that? Quadrant 2 because of this thought process. Ooh, I didn't do this the other hour. So I have to choose the negative. Ouch. It's a kick in the stomach. And then I proceed on. What happened? What did I do? Sine's positive in quadrant. I'm so embarrassed. Everyone be quiet. Everyone always hates me. All right. What if I did cosine of theta over 2 then? It'd be negative. Sorry. I apologize, everyone. I'm human. Wish I wasn't. Travel the cosmos. Part of the Star Wars universe. Cosine of theta is now I'm all nervous. Negative 3/4, right? Right? All over 2. And then this one, I'm going to prefer to do it this way. This is, oh heck, I don't know anymore. 4/4 plus 3/4 is 7/4 over 2, which is 7 over 8. Root, right? All right, and then you know what I'm going to do? Do you know what I'm going to do? I'm going to multiply both top and bottom by under the umbrella of a 2. Or on the umbrella squared a 2. Why? What's 2 times 8? Which is 4, and then you get root 14. Can't really think of anything else that simplifies there, and it is positive. All right, so that's a strange one. Right? What time is it? I know you know. All right. Before we do our identities, tell me the answer for 33. It's sine. Sine of 40 over 2. What's the next one? Tan of 147 over 2. Do it. I think you know the next one. How about this one? Ooh! Look at jerk Mr. Samulus. What's happened here? Yeah. It's a flip. What's the flip of tan? Cotan. So actually this is cotan of 8 theta over 2, right? Which is cotan of 4 theta. So that's just a flip of this. So that's a cotan rule. So here we go. Then back to these. The reason I do this one now is this is a little different perspective. These are strange. Really have to focus on this, and really it's specific to what we're doing today. Then when it gets in the grand scheme of things, when we're talking about the whole chapter, this kind of question will be kind of tough if you're not able to think this way. So I have to find the sine of theta, and I'm given what kind of information? Information from 2 theta. So you have to bridge from how do I get information knowing 2 theta into theta information. So I have to find sine of theta, and I'm in 5, 6. So theta is blank theta over 2. This is all you have to handle, and it's easy. 2 theta, then 2 theta is the argument now that can be inserted into my formula. That is the A in the formula for the half angle formula. So sine can't stand cosine. So, oh, wait a minute. Theta terminates in quadrant 1. What do I choose? See, that's why that information is there. You should always ask yourself, how do I know if it's plus or minus? They tell me something. There is something in there that it tells me which one it is. So every single time you choose the plus minus based off of information, knowing where the angle in question is located. And the angle in question is actually theta. Although I did a little trick here to use the formula. Square root of 1 minus, hates cosine, over 2. What is the Sorry, it's not theta, it's what? What's the argument? 2 theta. So I knew I made a mistake right when I wrote that. I tricked myself to allow the argument within the formula to be 2 theta. What is the cosine of 2 theta? So basically you just shove 3/5 in there and you simplify. How do you simplify? I don't know, I think I did a couple different things. This is 5/5. 5/5 minus 3/5 is 2/5. 2/5 over 2 is 2/10. 2/10 is 1/5. And then this becomes the square root of 5 over 5. I'll pause the video for any questions for how fast I rationalized. Oh my goodness, all this work. I didn't say any of that online. Okay, so it's the same thing as the last one where I tricked myself. Theta is 2 theta over 2. And then I can use this formula now, and I have part of the information. So that's actually all we discussed without me having a video on. What's this number right here? So it's 1 minus negative 24/25. All right, and then remember we don't have to choose plus or minus. But by the way, if 2 theta terminates in quadrant 3, where does theta terminate? And you would have to do that if it was sine or cosine. You'd have to choose the plus minus. All right, I made a mistake on that one. If it was a cosine of 2 theta over 2, then you'd have to choose the minus. All right, but this you don't. It's all built in. What can we expect as an answer? Minus. All right, I don't know. You could just do this if you don't even like thinking about fractions. And then this becomes 25 plus 24 all over negative 7, right? I didn't do anything wrong there, did I? And then this is 49, are you serious, over negative 7, which is what? Negative 7. Yeah! Okay, what do we get out of here? I have to ask that every day. It annoys everyone. Okay, now don't worry about all that blue. My notes got destroyed from second hour because of computer issues, so I printed it on. No, nobody cares. Let's just move on. What I did have for these notes though was the identities in front of me. So I told the students that you got to have these in front of you, and just keep staring at them, and they may or may not help. In this case, I think they do. So let me stick that right there. Paste. So I'm like the student that says, all right, I got to keep looking at this and trying to see how this helps me. Now, let's talk about this. What's sine 2x? You should know that right away. That's one you have to have memorized. 2 sine x, cosine x. Then what would happen next? The 2 sine x's would cancel. You have cosine x. and you have to turn that into cosine squared minus sine squared. I don't know if you'd be able to do that. Unless, I don't know, I actually can't think of it. So actually I can, and I did figure it out how that would happen, but many would not be able to. You know how? Cosine of 2 times x over 2. And then x over 2 becomes the argument, and it's the double angle property. Did anyone understand what I just said there? Raise your hand. So number one, the 2 sine x's cancel. You have cosine of x. You change cosine of x into cosine of 2 times x over 2. And then you use the double angle theorem with x over 2 being the argument. I'll move on. Or, what does it mean to be cosine squared? This is what I did this morning, and I figured it out. And it took like 5 or 6 steps. Cosine squared means you find the cosine of x over 2, then you square it. So what's the cosine of x over 2? Plus minus all this stuff. Oh, don't whine now. What time is it? And don't get, it's a here, but it's x here. X is the argument. But then it's squared. What's a positive squared? What's a negative squared? So it doesn't matter, this plus minus. You're going to get the same result. Freedom. And then what's sine squared of x over 2? It's whatever sine of x over 2 is squared. What is sine of it? It hates cosine, plus minus, square root of 1 minus cosine of x, all over 2 squared. So then the next step is, this becomes the freedom. Not plus minus. Minus. And it's still a little strange after this. And this is what hurts a lot of people. How do I deal with this minus sign? No time. You distribute it. And this still is strange because now you get 2 cosine of x over 2. And what's your inkling to do? What would everyone want to do right now? Cancel the 2's. But then look at the left. Those that don't consistently keep looking at the left side drive me crazy. You're only missing one thing, and what is it? What are you missing? What am I going to do? Top and bottom. 2. What am I missing? Now just do it. Oh, and then lo and behold, when I multiply top and bottom by sine x, what is the numerator? What is the numerator? The numerator is what sine 2x's rule is. And you done did it. Now, the other way that I verbalized, how many steps was that? 3? Maybe 4? So it was a little bit less than that for those that understood that. I don't know what just happened. Oh, that freaked me out. I thought we lost everything. What time is it, everybody? I hope I haven't been taping. That would be hilarious. Thank the maker, if there is one. All right, public school. Can we turn this into that then? Maybe with that, now I'm thinking that, changing cosine of x to 2 times x over 2. I don't know. I'm not going to do that. You know what I'm going to do with this? I'm going to do the same thing that I did over. You know what? This is in the way now. You got that work, right? This won't erase right here. All right. Now, equals. Do something. 1 minus. This is the one where I was looking at it, and I thought, hey, this is squared. When I square a square root, what happens? It goes away. So I'll put the plus minus. I'll put the 1 minus cosine A, x. Don't be converting variables or changing them. And then I'm going to square it. I'm going to do the same on the bottom. Over, I should put this equal sign right here. 1 plus, same thing. What time is it? Ah! Okay. Now, equals 1 minus cosine x. No matter what, I'll keep going on this video and talk by myself in the room. Over 1 plus 1 minus cosine x 1 plus cosine x. What do I do with this minus sign? Plus negative. Okay, then what I did is I believe I got a common denominator of the little fractions. So I'm going to go ahead and write this in red. If you had colors, go ahead and... No, I don't like it. Okay, so next, equals. Now it's red. What's going on? It's 1 plus cosine x plus negative 1 plus cosine x all over 1 plus cosine x. This is the numerator of the big fraction over, that's why I want to shove this over here. All I did is multiply this by 1 plus cosine x, or 1 plus cosine x. I don't know what I said there. Both top and bottom. Do you get it? To get a common denominator. And I'm going to do the same thing with this one. 1 plus cosine x plus 1 minus cosine x all over 1 plus cosine x. By the way, what happens to these 1 plus cosine x's? They should be canceled right now. And then what happens with these 1s and negative 1s right here? Cancel. Then I have 2 cosine x up at the bottom. And then what happens to the cosines? What's 1 plus 1? What's 2 cosine x over 2? Look at the left side. Boom, shaka. Anyone? Laka. Pew!